Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 12 of 2015 JEE Advanced Physics paper. So let us start with question number 12. Hello students, let us solve question number 12 of 2015 JEE Advanced Physics paper. The question is, in an aluminum bar of square cross section, this is an aluminum bar and this section is square, so each side is 7 mm. A square hole is drilled and is filled with iron. So this part you can see a square hole is drilled and that is how much? 2 mm. It's given 2 mm. This 2 mm. Each side is 2 mm and that hole is obviously square one and it's filled with iron, and that portion is filled with iron, so it is a combination of aluminum bar and iron bar. Iron bar is having side 2 mm and the aluminum bar is having side 7 mm, and when you find the area you have to subtract the portion which is filled with iron. Now the electrical resistivity of aluminum and iron are, the resistivity of these two metals are given, this and this respectively. The electrical resistance between the two faces P and Q, so this face will be Q, so this face will be P, this is P and this is Q, between these two ends of the composite bar will be. So you can just imagine that one bar is like this and another bar is outside it, so these two resistances are in parallel. So we have to go for the parallel combination of resistances. So we'll proceed like this, that the equivalent resistance R equivalent will be 1 upon R1 or aluminium plus 1 upon R iron. This is how you will find the equivalent resistance. So to solve this, you have to find individually the resistance for aluminium. That is, in general we know that the resistance of a conductor is given by rho L by A, where rho is the resistivity, or it's known as specific resistance. L is the length of the bar or conductor, A is its area of cross section. So in this case for aluminium, we have area of cross section which is this portion has to be subtracted because this is filled with iron. So for aluminium it is rho aluminium L by area of cross section of aluminium. This length is same for both and it is 50 mm given. So length I will put 50 for both, but then these two will change. So I will write this as rho L A, aluminium is 2.7, 10 raised to minus 8 ohm meter. This length is 50 mm and that in meter will be 50 10 raised to minus 3 divided by area of cross section of aluminium. It is 7 square side, so 749 mm square, and from which 2 into 2, that is 4 mm square, is subtracted. So this area will be 7 into 7 minus 2 into 2 mm square, which is 10 raised to minus 6 meter square. So if we solve this, then what we'll get? So let me write this resistance of aluminium, which is 2.7, 10 raised to minus 8 is here. So is minus 8 is here, 6 goes up, so it's minus 2, and this is minus 3, that's minus 5, 1 0 goes, so it is minus 4. So minus 4, and this 5 is there, divided by this is 49 minus 4, that is 45. That's all. This is the resistance, and 5 9s are, and this is we can write 27 divided by 9 into 10 raised to minus 5. 3 3s are 9, 9 3s are, okay, you can write 9 3s are 37. So write here 3. So it is coming out to be 3 10 raised to minus 5 resistance, that is ohm. So the resistance of aluminum coming out to be 3 10 raised to minus 5 ohm. And then we have to find the resistance of iron. The resistance of iron is rho of iron, length is m divided by area of cross section of iron. Resistivity of aluminum iron is given as 1 10 raised to minus 7 ohm meter, 1 minus 7 ohm meter, multiplied by the length, which is 50 mm, which is 10 raised to minus 3 meter, divided by area cross section of iron, which is filled with 2 and 2 by 2 side, so it is 4 10 raised to minus 6 meter square. This meter square and this meter square cancel, this is left with ohm. So now you can solve this by, this is going up, this plus minus 1, this is minus 4, and this is minus 3. So minus 3. And there is no more 0 left here, is 5 divided by 4 ohm. So this is 3 10 raised to minus 5, this is this. Then equivalent resistance we can write by calculating. So the equivalent resistance in case of two parallel combinations of resistances, the R equivalent, you can directly write the product divided by sum. That is product of the R aluminum, R iron divided by R aluminum plus R iron. Product of the resistance by sum of the resistance. So R AL value is 3 10 raised to minus 5, and that is how much it is, 5 by 4 10 raised to minus 3 divided by the sum of the two numbers, 3 10 raised to minus 5 plus minus 3. So we can do one thing, that 10 raised to minus 5 I can cancel. If I cancel that, then we are left with this is I'll take 10 raised to minus 3 cancel out, okay, then this will be minus 2 left, so this will be 15 by 4 into 10 raised to minus 5 divided by, from here it is 3 10 raised to minus 2, because it's minus 3 plus 5 by 4. Now we'll move to the next page. We'll see what is the value of R equivalent now. This is 15 by 4 times 10 raised to minus 5 divided by you can see here 10 raised to 15 by 4 10 raised to minus 5 divided by this one 3 10 raised to minus 2 plus 5 by 4. Okay, Now let us solve this. Now this is 10 raised to minus 5 is there. Here we'll solve it. This is 12. So 15 by 4, 10 raised to minus 5 divided by 4 is 12. 12 10 raised to minus 2 plus 5 divided by 4. Okay, this 4 and this 4 will cancel out, and this is left with 15 10 raised to minus 5 divided by, this is 5.12. If I for the time being we are asked to find the resistance of the composite bar, so it is divided by some number will there. This is answer should be in micro ohms. You can see that this answer should be in micro ohms. So this is in ohm we are getting. So multiply by 10 divided by 10. So 10 divided, 10 multiplied. This goes up micro, and this 10 is be 150. 150 divided by 5.12 and to 10 raised to minus 6 ohm, which gives us 150 divided by 5.12 micro ohms, and this number comes out to be how much it will be. Then if I have to solve it, because this number is not approximate number, this is in this form, so I have to solve it. This will be 15000 divided by 512 micro ohms. So then we have to solve it, keep on solving it till we get number. So divide by this is if I checked it, this is 512 divided by 2, or 5 I can divide. If I divide by 5, then it is not divisible by 5. So we divide by 4, then 4 1s are 4, 5 1, 4 2s are 8, 32, 4 3s are 12 and 30, 4 6 are 24, 4 7s are 28, 9 to 12. Okay, this will be divided by 4. So 4 1s are 4, 4 2s are 8, 4 8s are 32. So now if I divide by 4, then I will get here 4 3s are 12, 4 7s are 28, 4 5s are 20, 3 7 5 0. Again I will divide by 2, then I will move to the next page. This is 3750 divided by 128 micro ohms. This comes out to be, if I divide by 2, this is 64. This is 64, and this divided by 2, this is 321. Then 17. 17 2 8s are 16. 1 5 15, then 2 7s are 14, 105 micro ohms. So this comes out to be this value. This goes down to this value, and you can see here that if you see the options, 1875 divided by 64, 1875 divided by 64. So this option is correct one. So it is 1875 divided by 64. So option number 2 is correct. Okay, thank you.